until now, we've only created subnets that support the same exact number of hosts on every portion of the network. In this video, entitled, "We All Like to Be a Little Different," we're going to be looking at the world of Variable Length Subnet Mask, or VLSM. Now, we're going to look at it in two ways. If you're looking at trying to understand subnetting because you want to take the Network Plus test, they generally only ask questions to a certain level. They only want to know what subnet mask can support the certain number of hosts on each network. That subnet mask is going to be in a notation that is known as CIDR notation, that stands for classless interdomain routing. We have been dealing mostly with classes, a class A, a class B, a class C, but now we're losing all class entirely. Classless interdomain routing. If you're pursuing learning subnetting to take the Cisco certification, they not only want you to know what is the subnet mask or the CIDR notation, they also want you to be able to pick out what is the valid range of IP addresses for each subnet that you're creating. So, we're about to go be a little different with variable length subnet masks. In this video, I mentioned we're going to be going over a concept known as variable length subnet masks. And you may wonder, why is she starting with those 7 questions again? Well, because for the different types of exams, they only want us to go to certain levels. Let me explain what I mean by that. You will have questions if you're taking the Network Plus test. You will have questions on variable length subnet mask and the CIDR notation needed to support different number of hosts on every network. However, that's as far as it goes. They only want you to go to question number 4. What mask will support this number of hosts? So I will show you that. If you're taking a Cisco test, you will also have to deal with variable length subnet masks. And in that case, they're going to want you to give the valid range of addresses as well, more than likely. And because question 5 is going to change, because each time we get to a new network, we're going to have a different increment. I wanted to start with these questions and show you where this type of problem is adjusting these series of questions just a little bit. The question for step number 5 is still going to be, what is my increment? But it's not going to be the same increment every single time, because each network is going to support a different number of hosts. So, because almost everyone I know in IT is a little bit different, myself included, let's go be a little different. So I have this template that I have drawn, and I have labeled a number of different networks here. In fact, I have labeled in total 7 different networks. Now, 4 of them, the connection between a switch, that's what those rectangles are supposed to be, and the router, that's what the circle is supposed to be, I've listed network D, E, F, and G as having 2 hosts apiece. Why? I have to make connections on both ends. Now, I haven't filled in what I want for each of the other networks because I'd actually like to demonstrate this twice. So, I'm going to start with the largest amount, and that's how you typically have to solve a problem if you're doing variable length subnet masks. Find the network that you need the most hosts on, and then come down from there. And I'm also going to be doing this with a Class C network ID, just to go over the adjustments that we have to do in a Class C one more time. So in network A, I'm going to need 75 hosts, and I'm just picking these numbers randomly off the top of my head. In network B, we're going to need 50 hosts. And in network C, we are going to need 25 hosts. And then, as you already see, for network D, E, F, and G, only 2 hosts apiece. But what's our network ID? What are we starting with? Now, I don't actually need to give you the network ID yet. I will. Now, I've opened up a box, but I did that and then thought, I don't really need to give them that to simply solve for the level that needs to be solved for in the network plus. How many hosts per subnet do I need? What's the subnet mask to support that number of hosts? That's all we need to solve for. So for this type of problem, if you are simply trying to understand variable length subnet mask for the network plus test, the network ID is completely immaterial. All we need to do is use one of those 2 charts. So I'm going to actually use both. I introduced an Excel spreadsheet looking chart in the last video about subnetting for a certain number of networks, and I will be demonstrating how to come up with the mask with both charts. So first chart we're going to be using is that 8-line chart that we started the very first video with. And then we'll be going to that chart that I demonstrated in the last video on subnetting for number of networks. Now, on our first network, and I'm going to write it over here just so that we remember it, on our first network, network A, we needed 75 hosts. In network B, we needed 50 hosts, and in network C, we needed 25 hosts. So how many zeros? Because remember, we're solving for number of hosts. We're back to how many zeros do I have to keep? The very first value that is greater than 75 come all the way from the right to the left. So when I need 75 hosts, then I am going to need 7 zeros. That's how many I'm going to need. So it's going to be 2 to the 7th power. Okay? When I'm solving for up to 50 hosts, I'm going to need 6 zeros. So it's going to be 2 to the 6th power. And when I'm solving for 25, I'm going to need 5 zeros. So I now have what powers I need. It's going to be 2 to the 7th, 2 to the 6th, and 2 to the 5th. So going back to that chart that I showed you in the last video, the subnetting chart that shows you how you can quickly find what the mask is and the increment is. In this case, so far, we're only going to solve for the mask. Let's see what the mask is going to be for each one. So for network A that needed 75 hosts, we determined we would need 7 zeros. So coming up under a class C, we get to where it says 2 to the 7th power, and our mask is going to be 128. For network B, where we needed 6 zeros to support the 50 hosts that we needed, we went to 2 to the 6th, and our mask is going to be 192. And for network C, where we needed 25, it's going to be 2 to the 5th power, and our mask is going to be 224. So hopefully this further demonstrates how you can use this chart that I showed you initially in the last video on how to subnet for a certain number of networks. Let's go solve that variable length subnet mask problem to put in the subnet mask that is needed for each of our different networks. We solved that we would need 7 zeros to support 75 hosts. And this is acting like a class C. So we start with the default mask for a class C, which is 255.255.255. we need to keep 7 zeros, which means we're turning on 1 1 here, which is a 128. And if we do the CIDR notation for that, that is either 8 ones in the first octet plus 8 ones in the second octet and 8 ones in the third octet, that adds up to 24, and one more 1 in the fourth octet, which is a /25. Or you could take the number of how many zeros I'm keeping, which is 7 zeros. I could take the number of bits in the subnet mask altogether, which is 32, subtract 7, and that gives me 25. So either way I solve for it, the subnet mask for network A is going to be a /25. So now we're looking at the subnet mask that I need for network B. I needed 50 hosts. That was 2 to the 6th power, or keeping 6 zeros, which means I'm adding 2 ones. So I again start with the default. I add 2 ones, and when I add up 2 ones together, that is 192. And whether I'm adding all the ones together, 24 plus 2, or if I'm subtracting from 32, the CIDR notation is going to be a /26, because I had 6 zeros that I kept. And if I subtract 6 from 32, that gives me 26. Either way I look at it, the CIDR notation for network B is going to be a /26. Now, for network C, where I only wanted 25, we noted that we needed to keep 5 zeros, which means we're adding 3 ones. So it's 255, 255, 255, and from that chart, this is going to be 224. And if I do the CIDR notation, 24 straight ones in the first 3 octet plus 3 more is going to give me a /27. And again, I can simply subtract from 32 the number of zeros that I kept, which I'm going to keep 5 zeros. That's how many I needed to support 25 hosts, which again will get me to 27. Either way you solve the problem, it will work. Now, you may have noticed I didn't go over, well, how do I know how many is 2? This is another one of those weird ones that I actually suggest you memorize. I don't actually suggest you memorize much. 2 to the 10th power, close to 1,000, and how many I need if I'm only going to need 2 hosts. So let's go back to that other chart for just a minute so I can show you how many I need if I need 2 hosts, remembering that we're subtracting 2. So coming across from the right-hand side, this isn't going to be enough. And remember, we have to subtract 2. This, well, that's 2, but once I subtract 2, that gives me 0. But 4 minus 2 gives me 2. So 2 to the 2nd power minus 2, because we're solving for number of hosts, will supply the 2 hosts I need. And if I look at the other chart that I showed you, that's exactly what it shows you. You notice I have a line crossing out 2 to the 0 minus 2. Why? Because that doesn't leave any hosts. That's the number 1 minus 2. That's a negative value. 2 to the 1st is 2 minus 2. That still leaves me with 0. So the very first place that I can actually have any hosts is 2 to the 2nd power. So I'm going to need to keep 2 zeros in my subnet mask, and that's going to be a subnet mask of 252. So back to our problem that we were doing. For all of the other networks, D, E, F, and G, the subnet mask is keeping only 2 zeros in it, so it's 255.255.255, and I'm subtracting those 2 place values, 2 and 1, from 255. That gets me 252, which is a /30. There are 30 consecutive ones in this subnet mask. So if I take 32 and subtract the two places that aren't turned on, it will give me 30. And this is another one I suggest you remember. Anytime you only ever need two hosts, it's always going to be /30. And what we've done now is we have answered this question to the level that the Network Plus test tends to ask it. But we haven't answered the question to the level that Cisco tends to ask it. And now that we're answering it to the level that Cisco wants us to answer it, we now actually need a starting network ID. So let me give you a starting network ID. And I'm again going to pick a public address of 192.168.100.something. In each one of these networks, our increment is going to vary, but our first network always starts with a 1. Why did I say it that way? Well, mostly I was actually trying to say something else, but let me explain. It'll start with a 1 because the first network ID is 0. So I put in the first network ID of 0, and remember, I always have to add 1 to start the range, and then I subtract 2 to end the range. So the first increment is 0. But then we need to look at what is the increment for network A. And it's not going to be the same every single time. It's going to change every single network. So I start with 0, and I add to it the increment for network A, which is 128. So my next starting value for network B is a network ID of 128, to which I'm going to add 1 and subtract 2. But I now have another increment. Network B does not increment up by 128. It increments up by 64. So I'm going to take 128 and add to it 64, and the next network ID is 192. That will be the network ID for network C. Now I'm going to label all these in just a moment. So network C is going to start at 192 plus 1, subtract 2, because we're in a class C, but now I need to label D, E, F, and G. And what are those? That is incrementing up by 4. And I will show you that again in just a moment. So every single time we do a valid range of addresses, we have always started with network 0. So my network ID, my pattern for a class C, and you can go back and look at those list of questions, is network ID, network ID, network ID, increment plus 1 through network ID, network ID, network ID, next increment minus 2. So it'll be 192.168.100.1, adding 1 to the network ID of 0, going down to the next network ID, which is 128, and subtracting back 2. So it'll be ending the range at 192.168.100.126. So that is the range for network A. The range for network B, the network ID of which is 128, is going to start at 192.168.100, add 1 because it's a class C to 129 through 192.168.100. The next network ID is 192, subtracting 2 back because it's a class C through 190. That then gets us to what is the range for network C. And I'm going to have to increase my page size so that I even have place to write that information. My network ID for the class C does in fact start at 192. But what I forgot to do was add 32 to it, because that is the increment for network C. So 192 plus 32, which is my increment for network C, gives me a value of 224 as the network ID for the next network, or network D. Now, before I get any further, I want to give you the increments for network D, E, F, and G, because now I'm only adding 4. So if I take 224 and add 4 to it, I will then get a value of 228. If I take 228 and add 4 to it, I will then get a value of 232. If I take 232 and add 4 to it, I end up with a value of 236. And if I take 236 and add 4 to it, I then have a value of 240. So those are the rest of my network IDs. So let me actually finish the range for the C network 224. That's going to be my next network ID. My next increment is 224, and I have to subtract 2 from it. So the range for network C stops at 222. Now, I'm going to put it down on the lower level here, all the ranges for D, E, F, and G, because there's really not room to write it in my diagram here. So, and I'm going to write them a little differently because they only each have 2 IP addresses in it. So network D, my network ID is 224. Remember, I have to add 1 and subtract 2. So 192, 168, 100, add 1 to 224, which gives me 225. And when I subtract 2 from 228, that gives me 226. There's only those 2 IP addresses. For network E, it will be a very similar thing. I start at 192, 168, 100. The network ID is 228. I add 1 to 229. And when I subtract 2 from 232, I end with 230. For network F, I start with 192, 168, 100, dot, add 1 to 232 to get 233, subtract 2 from 236, and I end with 234. And the last one, network G, 192, 168, 100, add 1 to 236 to get to 237, subtract 2 from 240 to end at 238. So if you would like other examples, please feel free to contact me. The level to which they want you to go on the Network Plus is just to find the subnet mask. That is the much simpler math. If you're studying variable length subnet masks so that you can take and pass the Cisco certification, please ask for more help if you would like some additional practice. The hardest part about this type of question for the Cisco certification is remembering to add a different increment every single time. So overall, I started with the network ID of 0. I then added the increment for network A. That gave me the next network ID for network B, and then I added the increment for network B. I took the network ID for network C, then I remembered to add the increment to get me to the next network ID, which was 224. And then for D, E, F, and G, because they're all the same size, I simply added the same value of 4. So this is variable length subnet masking. If you have any questions, If you want any additional help, please contact me at the email address that will be in the outro to this video. If you like this video, please click like, subscribe. One more time, I promise you, if you ask for additional help, I will answer. Thank you. At the end of each one of these YouTube videos, I want to do what I do for every student I've ever taught at the end of every class. That is, give them a way to reach out if they want additional information. The email address that is associated with this series of YouTube videos is mgteach2024@gmail.com. One more time, that's mgteach2024@gmail.com. If you have any questions, want additional practice, whatever, please feel free to contact me. I promise you, I will answer you.